Okay, welcome to another episode of Reality Mathematics on Ice, where I teach you mathematics and guarantee that I'm teaching you while ice skating. Up until now, we've been just using quadratic expressions, and we've been manipulating those expressions, factorizing them, so that we can put them in a more usable form. Now we're going to explain how to use the null factor law to actually solve some real-life problems and some problem-solving problems as well. Now I'd like to point out that by the end of this lesson, I want you to be able to recognize the components of a quadratic equation, and I want you to be able to use all those processes we've been using in factorizing to solve for x in those quadratic equations. Before we start solving using our quadratic equations, we need to understand the null factor law. So our null factor law states that A times B equals 0. And when this is true, that either A has to equal 0 or B has to equal 0. Because the only way that I can multiply two things together and have the answer be 0 is for one of those two things to actually be 0 itself. Let's take an example of a pre-factorized quadratic expression. If, for instance, we had x minus 1 multiplied by x minus 3 as our quadratic expression, and we changed that into an equation by saying that this expression equals 0, well, here my x minus 1 is replacing my A, and my x minus 3 is replacing my B. So either x minus 1 must equal 0, or x minus 3 must equal 0, because that's the only way our whole expression will equal 0. Now, if you follow that logic through, you can see here that if x minus 1 equals 0, then x must be equal to 1, because 1 minus 1 is 0. Alternatively, if x minus 3 equals 0, you can see that x must equal 3, because 3 minus 3 is 0. So there are two solutions to this equation. Now, for all quadratic equations, at most, they will have two solutions. There may only be one solution, or there might be no real solution, but the maximum number they can have is two solutions. Let's start with a fairly simple explanation of using this solution process. So we have a ball that is thrown straight up, starting from 3 meters above the ground, with a velocity, that's an initial speed, of 14 meters per second. When does it hit the ground? Okay, so let's have a look at what we know. We know the initial height of the ball was 3 meters. We know the initial speed of the ball was going up in the air at 14 meters per second. And we know the acceleration of the ball, if you know a little bit about gravity, is approximately minus 5 times t squared. So we can form an equation from this information, and that equation is that the height of this ball will be equal to minus 5t squared plus 14t plus 3. Okay, let's factorize this quadratic equation. The first thing I want to do is take my negative out so that my first term is positive. And that way, if I multiply everything through by negative 1, I get 5t squared minus 14t minus 3. And that gives me a nice first term to work with as a positive number. Okay, moving on. Negative 3 can be factorized as negative 1 and 3, or negative 3 and positive 1. And 5t squared, for 5 being a prime number, means that we can only factorize that as 5t and t. Now we'll just have to try and get our orders correct. 5t multiplied by 3 gives me 15t. and t multiplied by -1 gives me negative t, and so I now have negative t plus 15t, which gives me plus 14t, which is not quite what I want, because according to this part, I want a negative 14t. So the easiest way to fix that is for our negative to go onto the opposite side. So now let's do that cross again. 5t multiplied by -3 will give me negative 15t, and t multiplied by +1 will give me positive t, and then t minus 15t gives me minus 14t, which is what we want as our middle term. Now that I have the correct cross, I can use my two factors into my equation over here. So now h is equal to minus 5t plus 1 multiplied by t minus 3. Okay, if we go back to the question, the problem that we were asked was, when does the ball hit the ground? Well, when the ball hits the ground, the height of the ball will be 0. So I can now write 0 equals 5t plus 1 or t minus 3. So given that my factors of my quadratic equation were 5t plus 1 and t minus 3, one of those two factors must equal 0 for this equation to be true. So using that logic, either 5t plus 1 equals 0 or t minus 3 equals 0. So if 5t plus 1 equals 0, then by rearranging our equation here, we would get t equals -1/5. And if t minus 3 equals 0, then by rearranging our equation, we would get t equals 3. So what these are telling us, that either the ball was on the ground 1/5 second before I threw the ball, or 3 seconds after I threw the ball. Since this result doesn't really exist in real life, there was no time 1/5 second before I threw the ball in my example, the only one we need to worry about is this one. It hit the ground 3 seconds after I threw the ball. This result, though, does still have relevance in mathematics and in algebra, so when we are solving other equations where negative numbers are relevant, then this may still play a role. Okay, so thank you for tuning in to Reality Mathematics on Ice. I've been your host, Mr. Ross, and I hope through this experience you have been able to recognize the components of a null factor equation, and you can now use your processes to factorize those equations and go on to solve them. Thank you very much.